Welcome to the deep dive, where we really try to cut through the noise and get straight to the insights that actually make a difference. Now, if you're a developer, I'm pretty sure you've been there, right?
Yeah.
Wrestling with those AI coding agents, the ones that promise the world.
Oh, yeah, definitely.
But, they often deliver more frustration than actual functionality. The clunky ones, the ones that need constant hand-holding, and just leave you feeling like you've lost control instead of, gained an assistant.
Yeah, it's a common pain point.
Yeah.
Really common.
It really is. But then there's Claude Code. And it just seems to be this, well, delightful exception. An AI agent that, as our sources put it, kind of just simply works. Whether you're doing really precise edits or just like vibe coding, some throwaway tool to test something out.
It handles both surprisingly well.
Exactly. It
Awesome.
feels genuinely helpful, maybe even happy-making, which is weird to say about code. So today, we're really digging into what makes Claude Code tick. What's the magic? And we want to go beyond just saying, oh, it uses Claude 4,
Right, because the model isn't the whole story. Not even close.
We're looking at the specific design choices, the things that make it objectively less annoying, maybe even better, than Cursor or GitHub Copilot, even when they might be using similar tech underneath.
Uh-huh.
We've been digging deep user reports, sure, but we even looked at intercepted network logs.
Yeah, getting into the nitty-gritty.
So think of this as your shortcut, a guide to understanding what makes an LLM agent good. Stuff you can maybe use in your own work, or just, appreciate good AI tooling when you see it.
And what's really striking, I think, is that the delight factor, it isn't just raw model power. It's really about how that power is channeled, how it's constrained through very deliberate design choices.
Design choices, yeah.
Architecture, interaction design. It's less about the sheer brain size, maybe, and more about the nervous system, the learned habits.
That's a great way to put it, the nervous system. And it's funny how often the simplest ideas end up being the best solutions for complex problems. Which brings us, I think, to the absolute core philosophy behind Claude Code. Keep things simple, dummy.
Huh. Yeah, blunt but effective.
It really is, isn't it?
It totally is. I mean, the basic idea is, look, LLMs are already super complex. They're hard to predict, hard to debug. We all know that. So when you start piling on more complexity, like multi-agent systems, complex handoffs between agents, or these really intricate RAG search setups.
Right, retrieval augmented generation.
Yeah, you're not just adding pieces, you're multiplying the difficulty, like tenfold. Debugging becomes a nightmare.
And those systems, they become fragile, right? Terrifying to change or scale.
Exactly. And that fragility ultimately just frustrates the user because things break in weird ways.
So practically, if you're building something like this, the advice is keep it simple. Maybe keep your agent code in one file. Avoid tons of boilerplate.
And be ready to just rip it out if it's not working.
Yeah, just rip it all out, as the source said. It's very pragmatic, very agile almost. Focus on what works now.
It reminds me a bit of that bitter lesson people talk about in other areas of AI, like self-driving.
Oh, yeah. How so?
Well, the lesson there seems to be that simpler end-to-end systems where the model learns directly from input to output often end up beating these really complex, hand-engineered systems with lots of separate parts.
Because the simpler system lets the model just learn more effectively.
Kind of. It lets the model cook, as they say. Less interference from complex, brittle engineering.
And Claude Code really seems to take that to heart. Architecturally, I mean. You hear all this buzz about multi-agent systems, right? Like it's the future.
Yeah, it's definitely the rage.
But Claude Code just doesn't do that. It sticks to one main loop.
Okay.
One message history.
Pretty much. It keeps a single main thread. Now, it does do some smart things periodically, like using prompts to summarize Git history.
Okay.
Or it clobbers the message history, basically squashes it down to keep the context tight.
Ah, like consolidation.
Exactly. And it uses prompts for some UI things, too. But fundamentally, yeah, it's a flat list of messages, which makes the control loop incredibly simple. Easy to understand, easy to debug.
And that reliability, that's key for the user experience. Less weird errors.
Totally.
Okay, so simple loop. But coding isn't always simple or linear. What about complex tasks? The ones with multiple steps?
Yeah.
Does it just hit a wall?
No, it actually has a pretty neat solution for that, which avoids the whole multi-agent mess. The main agent can basically clone itself, create a sub-agent.
Okay.
But here's the key constraint. Maximum one branch. So one sub-agent at a time. And that sub-agent cannot create more sub-agents.
Ah, so no infinite recursion of agents spawning agents.
Exactly. And when that sub-agent finishes its task, its result just gets added back to the main message history, tagged as a tool response.
Gotcha.
You combine that capability with an explicit to-do list that the agent maintains for itself.
A to-do list.
Yeah, and suddenly it can break down complex problems, tackle subproblems one by one using these temporary subagents, but without ever losing sight of the main goal stored in that to-do list.
That's really clever. It's like controlled decomposition without the architectural nightmare.
Precisely.
And here's something else that surprised me. It kind of goes against the bigger is better grain. Over half, more than 50% of the important LLM calls Claude Code makes aren't even to the big models. They're to Claude 3.5 Haiku.
Yeah, the smaller, faster one.
Right, the one that's like 70–80% cheaper. Why? What's the trick?
It's all about efficiency. Haiku is perfectly capable for a lot of tasks that just don't need the heavy lifting of Sonnet or Opus or GPT-4.
Like what kind of tasks?
Think about reading a large file just to understand its structure, or parsing a web page for specific info, processing Git logs, summarizing a long back-and-forth conversation to fit it back into context.
Okay, yeah, those don't necessarily need deep reasoning.
Exactly. Or, even get this, generating a quick one-word label describing what it's processing for every single keystroke the user types. Haiku can do that instantly.
Wow. So it's using the cheaper model liberally for speed and cost savings on these less complex cognitive tasks.
You got it. Saves a ton of money and keeps things snappy.
So the takeaway for you listening is pretty clear. Don't just default to the biggest model. Be smart about it. Use smaller, cheaper models where they make sense. It's just good engineering.
Absolutely. Use the right tool for the job. Okay, so that's the architecture and model use, but how does it actually tell the model what to do, especially with all these constraints and preferences?
Oh, the prompts. This is where it gets wild.
Yeah, the prompt engineering is seriously elaborate. We're talking huge prompts. The main system prompt is around 2,800 tokens.
Okay, that's chunky.
And then the descriptions for the tools it can use, that's another 9,400 tokens.
Oh, almost 10,000 tokens just defining the tools.
Yeah, filled with detailed instructions, examples, heuristics, reminders, really detailed stuff.
And that's before you even add the user's actual request and the conversation history.
Right. And often the user prompt itself includes this special file .claude.md.
Yes, this claude.md pattern seems like a massive unlock. You should definitely pay attention to this if you're building agents.
Totally. It's basically a context file for the AI specific to your project. Think of it like a readme just for the agent.
Like cursor rules or maybe an agent.md file people might have seen.
Exactly like that. It's where you, the developer, tell the agent things it just can't guess from the code. Like, always skip the node modules folder, or prefer using the requests library, not urlib, or follow these specific formatting rules.
Stuff that's crucial project context or just your strict preferences.
And the difference it makes is apparently huge. The analysis said performance is night and day with versus without Claude.md.
And it gets sent with every single request.
Every single time. So the agent always has those guardrails fresh in its mind.
That makes so much sense. And others are picking up on this pattern too, right? Like Minusx.
Yeah, Minusx introduced Minusx.md for the same reason, codifying user or team preferences. It's just a really smart way to provide persistent context without loading the main system prompt even more.
Keeps things cleaner.
Definitely. And inside those massive prompts, Claude Code uses structure really well, lots of XML tags and Markdown.
XML tags, like...
So, for example, they use system reminder tags, often at the end of sections. Seems like they're used to remind the model about things it might otherwise forget mid-task.
Any specific examples?
One clever one was reminding the model that the to-do list is currently empty, but explicitly telling it not to mention that fact to the user.
So controlling the output, keeping it less chatty.
Exactly. And then there are good example and bad example tags.
Oh, that sounds useful.
Super useful. They use these to show the model preferred ways of doing things when there might be multiple valid options.
Right.
Like maybe showing PyTest foobar tests is good, but CD foobar and PyTest tests is bad. It clarifies the preferred pattern.
Got it. Removes ambiguity, pushes the model down the right path, especially for stylistic or efficiency choices.
Exactly. It's really explicit guidance. And then Markdown is used more structurally, just with headings like tone and style, task management, tool use policy, makes the huge prompt readable, maintainable.
Okay, so simplicity in architecture, smart model use, and incredibly detailed, structured prompts. What about how it interacts with the code base, like searching for stuff?
Right, tooling and search. And here, Claude Code is something pretty different from a lot of other agents. It basically rejects RAG.
No retrieval augmented generation for search. That's kind of the standard, isn't it?
It is for many, yeah. But Claude Code Search is more like a human developer would.
How does that work?
It uses powerful command line tools, things like ripgrep for super fast text search using patterns, JQ for handling JSON data, find for locating files. Because the LLM understands code structure, it can build really sophisticated ripgrep commands with complex rejects, for instance.
So it's using the LLM's intelligence to drive traditional search tools smartly.
Exactly. Or it might use Haiku, the smaller model, to just read the first 20 lines of a file to figure out what it is, instead of embedding the whole thing.
Okay, but why is that better than RAG? What's the advantage?
The main thing is avoiding RAG's hidden failure modes, as the source calls them.
Hidden failure modes.
Yeah, you know, the weirdness you get from embedding models, similarity functions, re-rankers, deciding what's relevant, how you chunk up big files. It can all go wrong in ways that are really hard to debug.
Right, the black box problem. Why did it think this random chunk was relevant?
Exactly. With the LLM driving tools like ripgrep, it's much more transparent. The LLM formulates a query, runs it, gets results, easier to understand, easier to fix, fewer moving parts.
And probably easier to improve with techniques like reinforcement learning down the line?
That's the thinking, yeah.
So-
It's kind of like the camera versus LiDAR debate in self-driving, maybe. One relies on direct interpretation, the other on more abstracted data.
That's a really good analogy. Anyone who's fought with RAG chunking or embedding mismatches will probably appreciate that directness.
Definitely shifts control back towards understanding.
So what about the tools themselves? Does it just use low-level stuff like ripgrep and bash?
It uses a mix, actually, which is smart. There are low-level tools like bash, read, write, then medium-level ones for common tasks like edit, grep, glob,
Okay.
and even high-level, more composite tools like task, which probably interacts with that to-do list, web fetch for getting external info, and even one called exit plan mode.
Interesting. So why the mix? Why not just give it bash?
It's a trade-off. For really common, critical things like searching grep or finding files, glob, having a dedicated tool ensures it does it accurately and efficiently using the best flags, etc.
Right. Avoids the LLM messing up a complex command.
But it still has the generic bash tool as a fallback for less common and unusual situations where a dedicated tool doesn't exist. Gives it flexibility.
And the high-level ones like web fetch.
Those are efficiency plays. Instead of the LLM having to figure out how to use curl or whatever with multiple steps, web fetch just handles it, keeps the LM focused on the main task, stops it getting bogged down.
Makes sense. And I assume the prompts for these tools are also super detailed.
Oh, yeah. Elaborate descriptions, examples, guidance in the main system prompt about when to choose which tool. It's all very orchestrated.
Okay, so we have architecture, models, prompts, tools. What about keeping the agent on track during long tasks? You mentioned that to-do list.
Yes, agent self-management. That to-do list is crucial. It tackles this problem called context rot.
Context, right?
Yeah, where an agent starts off fine, but over a long interaction, it kind of loses the plot. Forgets the original goal, gets sidetracked. It's super frustrating.
I've definitely seen that happen.
So while multi-agent systems try to solve this by delegating, which can have its own context issues between agents,
Right.
Claude Code uses this explicit self-maintained to-do list within its single thread.
Simple, but effective.
Very.
Well-
The agent is heavily prompted to constantly refer back to this list. It keeps it anchored to the overall goal. Plus, it gives the agent flexibility. It can look at the list and decide to change course mid-task if needed.
And you mentioned it uses interleave thinking with the list.
Yeah, that ability of models like Claude 3.54 to weave reasoning and action together, it lets the agent dynamically add new items to the to-do list or even decide to reject a planned step based on new information. It's quite adaptive.
So the to-do list isn't just static, it's a dynamic plan. That's cool.
Exactly.
All right, last big area, refining the behavior, the feel of the agent, tone, style, avoiding stupid mistakes.
Yeah, the aesthetic side and also the safety rails. Claude Code controls its tone, style, how proactive it is, all through detailed sections in the system prompt.
Like actual instructions on how to talk.
Yep. Things like do not answer with unnecessary preamble or postamble, keep it concise, or if it can't help with something, do not say why or what it could lead to. Basically, don't sound preachy or make excuses.
Huh. Avoid the preachy AI. Good goal.
Or even only use emojis if the user explicitly requests it. very specific stuff to shape the interaction style.
Makes it feel less like a generic chatbot and more like a focused tool.
Right. But then there's the steering away from problems in the landmines.
How does it handle that? Is it subtle?
Not always. The sources show that, honestly, the current state of the art still involves a lot of shouting in the prompt.
Shouting?
Yeah, liberal use of all caps keywords. Important, very important, never, always.
Seriously? Like that actually works better?
Apparently so for now. It seems to be a reliable way to really hammer home critical constraints.
Examples.
Things like, important, do not add any comments unless asked. Or, very important, you must never generate or guess URLs.
Wow. Okay, so a bit brute force, but necessary to keep it predictable and avoid common pitfalls.
Seems that way. Maybe future models will be more nuanced, but for now, loud keywords seem to work.
And one final point from the analysis, algorithmic prompting. Sounds important.
It really is. The idea is to actually outline the agent's main job as an algorithm or a flowchart within the prompt.
So literally describe the steps it should take.
Kind of. You role play as the LLM. Think about the decision points it will face, and you write those down explicitly. First, check the to-do list. Then, decide on the next tool. If using tool X, remember why.
Structures its thinking process.
Exactly. What you don't want is just a big soup of do's and don'ts.
Why not?
Because in really long prompts, those lists of rules can start contradicting each other or become ambiguous in certain situations. Makes the model fragile, hard to predict, hard to update.
Whereas an algorithmic flow provides clearer guidance.
Right. Claude Code sections on task management, doing tasks, tool usage policy, they read like clear walkthroughs of its process.
Fascinating. It's like giving it a standard operating procedure.
Pretty much.
Okay, so let's try and wrap this up. We've dived pretty deep into Claude Code's magic here. The success, it seems, isn't just one thing. It's not just the model.
No, definitely not.
It's this combination of ruthless architectural simplicity.
Keep it simple.
Right. Then, incredibly detailed, structured prompt engineering using things like claude.md and specific tags. Thoughtful tool design, that mix of high and low level, leaning on LLM-driven search instead of maybe Yargar.
Yeah, avoiding those hidden failure modes.
The self-managed to-do list to fight context rot and keep it on track.
Super important.
And finally, that explicit control over tone and behavior, even if it means using all CCAP ES sometimes.
Huh. Yeah, even the shouting.
It's really about building a fantastic harness for the LLM, isn't it?
That's a perfect way to put it. It's a blueprint, really, for building agents that people actually like using. Agents that reduce friction instead of adding it. Build a good, clear, simple harness, and then, yeah, let the model cook. Don't over-engineer the cage. Just give it the right structure to do its thing well.
Delivering that just works feeling.
Exactly.
So here's something for you, the listener, to think about. Based on all this, what existing tools or workflows in your own daily life, maybe a coding task, maybe something else entirely, feel clunky or annoying? What could be Claude codified?
Interesting question.
Could you design a simple agent to tackle that recurring annoyance? And if you did, how would you start? Would you jump straight to complexity? Or would you try focusing first on that architectural simplicity? Maybe just one loop, one clear goal, maybe that explicit to-do list, and see how far that gets you.
Because maybe the real elegance and the most useful result actually comes from that restraint.
Something to chew on.